Let's take a look at this example. This time we're supposed to find the values of resistor R3 and resistor R4 in order to design the constant current source. So, from where we're supposed to start solving this problem? I would start solving this problem from drawing the voltage sources, okay? So please realize that resistor R3 and diode D2 are connected to the negative terminal of the power supply, which is called VEE. Okay, and positive terminal of VEE is connected to the negative terminal of VCC, which will go somewhere to the circuit. Okay, this is positive terminal, this is negative, this is my VCC, and this is of course my ground. Next, I'm supposed to find the voltage at the base of the transistor. Why? Because the voltage at the base of the transistor is going to be equal to the voltage across resistor, and I know the voltage drops across these two diodes, which is equal 0.67 volts, and I know also VBE 0.63 volts, which is going to help me to find voltage across resistor R3 if I know voltage at the base. So let's find voltage at the base first. Okay, so we have VB, okay, is going to be nothing else, just the voltage, okay, between this point and ground. And simply write that my VB is nothing else, just VD1, okay, voltage between this point and ground, VD1 plus VD2 plus VEE. Okay, so I have VB equals VD1 is given 0.67 volts, 0.67 volts plus 0.67 volts plus VEE, which is equal negative 15 volts. So VB is equal negative 13.66 volts. Okay, so this is my VB. Next, I'm supposed to find the voltage at the emitter. VE is nothing else, just VB minus VBE. So VE is equal VB negative 13.66 volts minus VBE, and VBE is given is 0.63 volts. So I have 0.63 volts. This is equal, so I have 13.66 negative minus 0.63. This is equal negative 14.29 volts. Okay, so this is my voltage at the emitter of my transistor Q3. Now I can find voltage VRE. Okay, VRE, or other words VR3. Anytime I say VRE, this is the voltage across the resistor which is connected to the emitter of the transistor. So this is VRE, or in our case this is VR3. VR3 is simply VE minus VEE. Okay, so this voltage minus this voltage will give me voltage across this resistor. So I have VRE equals VR3 negative 14.29 volts minus VEE, and VEE is negative 15 volts. I have negative 15 volts. This is equal 710 millivolts. Okay, so this is the voltage across resistor R3. Now, because I have the voltage across this resistor and I have current which will go through this resistor, keep in mind that the current which will go through this resistor is approximately equal to IC, okay, because IB has very small value. So let me write this down. IE is approximately equal IC and it has value of 3.2 milliamps. Okay, this is also my IR3. Okay, so I have R3 is equal VR3 over IR3, where VR3 we found is equal 710 millivolts. So I have 710 millivolts divided by IR3, which is equal 3.2 milliamps. So I have 3.2 milliamps. Okay, so this is equal 710 exponent 3 negative divided by 3.2 exponent 3 negative. This is equal 221.87 ohms. So this is 221.87 ohms. Okay, so this is the value of the resistance of resistor R3. You know, in real life you are going to use the resistor R3, right, equal to 220 ohms, because you are not going to find the nominal value of the resistance 221.87 ohms. You are going to find for sure 220 ohms. So this is the value of the resistor which you're supposed to use. Okay, so next, in order to find resistance R4, you're supposed to keep in mind that IR4 is approximately equal to IR3. Okay, and this is equal 3.2 milliamps. Okay, so next, VR4 voltage across resistor R4 is equal to the voltage at the base. Okay, because the base voltage is measured from the base to the ground. So I can say that my VB is equal to VR4. So VR4 is equal negative 13.66 volts. Okay, and now one more thing, because the current through this resistor is going to go in this way, so it's going to go from, and by the way, let me remind you that we use the conventional current flow, so we assume that current flows from positive terminal to negative, so current is going to flow through the base, from the base will go through the resistor. Okay, so anytime current is entering the component, we write positive sign, right? Anytime we'll leave the component, we're supposed to write negative sign. I mean, current is leaving the component, negative sign. So if you are going to look from the base, okay, you will see negative sign first. So if you are going to calculate resistance R4 is equal VR4 over IR4. So VR4 is equal negative 13.66 volts divided by IR4, 3.2 milliamps, but because we are looking at this resistor from the base, that's why I'm going to write over here negative sign. So negative and negative will cancel out because resistance cannot be negative, and this is equal 13.66 divided by 3.2 exponent 3 negative is equal 4.26 kilo ohms. So this is 4.26 kilo ohms. Okay, keep in mind that negative and negative will cancel out, and if you want to build a circuit, you're supposed to choose the resistor 4.2 kilo ohms. Okay, this is going to be your R4, because it's going to be kind of hard for you to find 4.26 kilo ohms. Use 4.2 kilo ohms. Okay, so we found the values of resistors R4 and R3, so we can say that the problem is solved.